Today's question is 119, Pascal's triangle 2. Given an integer row index, so row index will be the input, return the row indexed row of the Pascal's triangle. So whatever index we have been provided, we will be giving the content of that particular row. So in our case it is 0, it is 1, it is 2, and here comes 3. So we are going to give this output 1 3 3 1. Okay. So it also says in Pascal's triangle each number is the sum of two numbers directly above it as shown. So the basic idea how Pascal's triangle is created is by adding the two numbers directly above it as shown in the interactive visualization. So it's like 1 and 1 is getting summed up to give 2. Similarly 2 and 1 is getting summed up to give to populate this location as the value 3 with the value 3. So I have a Pascal's triangle with all the coordinates into it, and in order to visualize it more and then come up with few fun facts. Okay, the very first thing about the Pascal's triangle which is worth noticing is that all the value at the edge will have the value 1. Blindly we can say this is going to have 1, this is going to have 1, similarly this. Okay, all the edge value will hold the value 1. Okay, so this is the first important visualization. Right after knowing that we are going to deal with the Pascal's triangle, we should understand the edge value. All the edge value is going to hold the value 1. So which value are we going to calculate? We are going to calculate the value in between these ones. So these are the value which we are going to calculate. These are the locations for which we are going to calculate. So the second important thing is how to calculate. So first, at edge the values will be 1. Second, find the places for which we are going to get the value, and the value is calculated with following style. So for an instance, if I am going to get calculated for 2 and 1, then the idea is that we will be adding these two guys to get the value. 1 and 0 and 1 and 1 will be summed up to get the value for 2 and 1 is what I am going to write here. So 2 comma 1 will be equals to 1 and 0, similarly 1 and 1. So this is the observation by looking 2 comma 1. Similarly for 3 comma 1, these two will be summed up, and for 3 comma 2, these will be summed up. So same thing goes here. You will shortly notice that why I am writing this. So for 3 comma 1, we are summing the value at the location 2 comma 0 and with 2 comma 1, and similarly for the location 3 comma 2, we are adding the value at location 2 comma 1 with 2 comma 2. You can pause the video, see how I'm writing these. It's basically picking the right above two values, nothing else, and that will make more sense, and you will exactly know why I'm doing this. If you still do not get it, here is the reason why I'm doing it. So I want to generalize this, that how, if I say that I'm at location I comma j, then how will I know that for what all location I comma j, what exactly, okay, sorry for that again, I comma j, what will be the coordinates in which I need to pick the value from. So that is why I'm giving the examples for 3 different locations, so that I can generalize it for the further uses. So it is 1, it is 2. If I say that I am dealing with location I, then you can see all the I location 2, 3 and 3 have been decremented by 1, making it 1, 2 and 2 respectively, in order to get the coordinate at this location. So basically this is I minus 1, comma. Similarly, if this is j, if this is j, and if I look at all the jth location value, then it's decremented by 1 again, so it's j minus 1. If I further visualize this, so 1 and 2, all the relation of I with the ith location at this end is again decremented by 1, so I minus 1, and j is copied as it is, so it's 1 1 2 1 1 and 2, so j. So this is the generalized formula which will help us in the random location where we are interested to find the value by summing the value right above it. So these are the two important observations which we need to right away understand if we are dealing with the Pascal's triangle, that the edge value will hold value 1, and there will be some location for which we need to fill the value where we are going to sum the value from these two locations right above it. Okay, so I minus 1 is itself telling us that it is right above it. Okay, the another important thing which is worth noticing, that this is I actually, okay, and this is j. So this is I, so the I is going to help us to get the value immediate above it, right? So I minus 1, that is basically helping us to get the value right above it. So that makes sense why we are doing I minus 1 and j minus 1, because we need to get right above it and immediate next each other value, right? So 1 will be obviously left to it and 1 will be on top of it, so the top of it has j, and right to the left of it will have j minus 1. So these are the few important points which we need to understand right after knowing that we are dealing with the Pascal's triangle. And after this, I think we can go back to the question and see that what is the requirement. Okay, so we have already discussed about the requirement, that we will be provided with the row index, and we are going to give the content of that particular row. If it is 0, then it's 1, and if it is 1, then it's 1 1. All right. With the following concepts which we have discussed, we can get started. So the very first thing which we need to understand here is that we cannot jump to location 3 and get the value 1331. We need to build the Pascal's triangle till 3 to get the value of 3. Okay, because we will have to deal with the values on top of it, and for that we need to build this triangle. So that is one thing. So when since we have two vectors I and j, we clearly know that we are going to create two vector of the integer type. And since this is for the temporary purpose, because we are creating it because we need to fill the value, and question is not asking for this, so I'm just making it temp. Then comes the indexes. So int I equals to 0, it will go till I less than equals to the row index. Y less than equals to, I'll come back for that. I'll come back on that. So if I is less than equals to row index, generally we write less than, right? So less than equals to, because if you can observe here, right, when row is 3, so there are a few things which is worth writing here. Let me clear this up. So I'm writing about this, and this. Okay, so this is 0, this is 1, this is going to be 2, this will be 3, and this is 4, and this these all are I. This is I, and this is 0, this is 1, this is 2, this is 3, and finally 4. This is j. Okay, so these are the important things. And now coming back to I less than equals to row index, why I have written why not I less than row index, because if you see the question is asking for 3, the question is asking the value at the location 3 or third row. So if I say less than row index, then it will be till second, right? But it is asking to the third location, and it's ideally fourth location if you go by 1 2 3 4 concept, right? So from 0 it is actually asking for the third location and then get the value. So example number 1 itself will help you to understand more detailed way. By pausing the video, you can understand that why I'm writing less than equals to, because it is directly asking, it is not saying that less than 3, it is asking at 3. So if you go at 3, since the indexing starts from 0, you need to write equals to. That's the first thing which we need to write in the question while solving it. Then followed by, once you have written the indexes for the I, you are going to handle the j. But before that, we need a vector for handling all the value in j run, so that will be row. Okay, and for int j equals to location 1, and j will be less than I and j plus plus. I'm going to explain this j iteration as well, because it is also worth noticing that how j is smartly skipping location 0 and location 4. All right, so we know that okay, before that I missed it, sorry. Before that, okay, so it should be I plus 1 and it should be 1. Okay, before knowing how j is working, it's very interesting to understand how this row vector has been created. So row vector has been created to hold the value of single row. So this row is holding 1, and then in another go 1 1, then in another go 1 2 1, and each time once the row is completed, it is then getting it is getting populated to temp. I'll tell you how and when we are going to copy that to the temp. But before that, we should understand the relation of I and the size. So here is size. Okay, so if I talk about the sizes of these location, the size, minimum size is 1, right? And it goes to 2, then 3, then 4, and then finally 5. So if you see the relation of I and the relation of I and size, it's always I plus 1. If the index is 0, the minimum size is 1. If index is 1, it is plus 1, so the size will be 2. If the index is 2, the size will be 3, so on and so forth. So that's what I have written here. I'm creating a row with the size of I plus 1, because if the index is 0, then I cannot create a size with 0 size, right? It has to be at least of size 1, and all the value in first go will have 1 in it, because I know that all the values at these locations will be 1, right? So all the s values will be 1. So I do not want to recalculate it, so I'm going to give all the value as 1, and then we'll overwrite. Okay, let me just erase it again. And what is my intention, that once I calculate all the values, once I create the row with all the values filled with 1, I'm going to recalculate the value in these locations. Basically, I'm going to override the value. So in first go, all the positions whatever we will be building will have value 1, then we'll get this value and solve it. So that was the whole idea about this line. So what is the size and why all 1? Then let's see how j has been very smartly initialized by 1 and going till I. We know that location 0 and the location 4, which is equals to I, right? These two locations are something, these two locations will be something which we are not interested in, because we already know that this value will be 1, right? So that is why I have said that, hey, I want my j to start from 1, because 1 is the place where it is worth calculating. 0 is the place where we know that it has to be 1. So I'm starting with j equals to 1. Then why less than I? Why not less than equals to I? Because see, this is less than equals to I, which is the last location, and we want to skip the last location. So basically first and the last location has been skipped, and that is when it is equals to 1 to less than I. I hope that makes sense. Then we are going to populate the jth location. It is row, and this place we are going to do the same thing what we have done. The temp, what we have just discussed in the whiteboard, right? So it's like I minus 1 and j minus 1, and summing the value that with temp of I minus 1, the previous row with the jth location. Once you're done with this you have created the row, you have filled all the value with 1, then you have overwritten the location which you are interested in, and then finally you push this value to the temp, push back the row. Okay, this is important because when dealing with the previous values, we need the temp location because row will be moved to this index, right? And we want to deal with this index. So who is going to give the value from this index? Temp will help us in that case, and that is why we are building temp. But the question is not interested to build the entire Pascal's triangle. It is asking us that, hey, when you are hitting the last arc, you need the row index, right? So you just iterate through all the possible location, and when you hit the row index which has been passed as an argument to the function, you can return the row, because that is what my question is asking, right? And for any reason, by any chance we were not able to go inside this for loop, then we need to return the null. We need to return null or empty vector. So that's the whole idea of this question. Let's run it and see if this works or not. Okay, it got accepted. So basically what we're trying to do here, I just want to give a quick recap that we are trying to build the Pascal's triangle in order to get the previous value. Just because of this previous excess of elements, we need to build the triangle. Then we are going to go from 0 to the index which has been passed as an argument, and then we will be creating the row index. Once we create the row vector. Once we create the row vector, we are going to initialize it by 1, and we are going to create the size minimum of size 1. And we have clearly seen the relationship between size and I. Then we are running for the column, because row has been handled. Now it's time to column. It's time to iterate through the columns, and we understood that y it is starting from 1 and y it is going till less than I, not equals to I. Then we are going to calculate using the formula which we have derived by the observation, this one, ing and ing relation. Then finally, after all this calculation, we are going to push each row. Each time there will be one row at a time we are going to deal with, and each time when we are done with a row, we are going to push that into the temp, so that we are building the triangle parallelly. Once that is also done, the question is asking us to get the content of the given row. So once that I hits to the row index, whatever has been passed as an argument, we are going to return the row, because row is holding the value of a particular row with all the values, right? So we are going to return. For any reason, if we are not able to go inside this for loop, we are going to return from here. That's all the idea of that is the basic idea of the question. Let's just try to submit it. If it gets accepted, bingo, it got accepted. So I hope you enjoyed this video. Thank you very much.